Hey, this is Don from Padlock Technologies again with another video. This time we're going to talk about what we talked about in the theory in the other video, which was seamless or unified MPLS. Now we're actually going to do it. So here is the environment here. So we have one big ASN, BGP ASN, which is 65001. But as you can see, we have three separate routing domains. We have OSPF1 on the left-hand side. We have an ISIS domain. And I know you guys are always like, why you do ISIS? Well, I like ISIS. It's a lot simpler than OSPF from a configuration standpoint. There is one thing you just got to get over, which is the the network identifier. Once you get past that, it's pretty much like OSPF. And if you're going to do things like SDA or ACI, if you want to know stuff that's under the hood, you pretty much got to learn ISIS. It's a lot more flexible than OSPF in terms of new capabilities. OSPF, you pretty much got to write a whole new protocol for it. ISIS, you're just going to write a new TLB for it. And that's why ISIS can do IPv6 and IPv4, but we've got OSPF, you got OSPF v2 versus v3, which is IPv6. So we have an ISIS domain 51, and then over here, we have OSPF 2 area 0. All right, so we have different OSPF areas or ASNs, and then we have one ISIS domain. Now, I'm going to be honest with you here. When I was labbing this up, I haven't done this in a while. So I was labbing things up. I was making like little mistakes, and I was like, oh, I can't believe I did that. One of those mistakes were, and you'll see, I was advertising a loopback in the BGP, and I gave it a /31 and not a /32, and it would not, I could get traffic to go through, and then I kept going and doing some troubleshooting, and I looked, and I was like, oh, I made it a /31 instead of /32, but I'm advertising a /32 in the BGP. And as you all know, if you don't know, in BGP, you have to have that exact route in the routing table before you can advertise it. If you just advertise it and it's not in the routing table, it will not advertise. And you'll run into a bunch of problems there. So, what does this look like? Basically, each routing domain doesn't know anything about anything in the other routing domain. So OSPF 1 doesn't know anything about ISIS domain 51 or OSPF 2, and vice versa. Now, ISIS, though, has the loopbacks of 4, 7, 5, and 8 in each domain. So 4 and 5 is in ISIS domain 51 and OSPF 1, and then 7 and 8 is in ISIS domain 51 and OSPF 2. That is very important because what you're going to see from a trace route perspective is you're going to see 3 labels, right? You're going to see the BGP advertised label for the PE. You're going to see the service label, which is the VPN label, and then you're going to see the label to get to the ASBR, which is 4, 5, 7, and 8, right? So you're going to see 3 labels in the trace route. Now, why are you going to see that? Well, we have VPN v4 and we have MPLS L3 VPN routes. So it's an IPv4 route, which is, if I gave you a quick quiz on my last video, how many bytes is that? Well, remember, your RD is going to be 64 plus 32 for the IPv4, which is 96. So 96 for VPN v4 route, 192 for VPN v6 route. If you are studying for these exams, you should know that because they may ask you that question. So what you're going to see here from a VPN v4 perspective is it's going to say, hey, to get to the other PE on the other side, here's the other PE's loopback. Well, that loopback is not redistributed in the IGP. It's actually advertised to BGP. So that's why you're going to see that third route, that third label that advertised, or that PE loopback that's advertised via BGP. Then you'll see the ASBR loopback, because, or the ABR label, or ASBR label, as it goes through each routing domain, because we're going to see the special command. There's 2 commands. There's a send command in BGP, and there is a next hop self all command. Now, I've only seen this in iOS XR. I haven't seen it in iOS XE, and it's definitely not. I only see this in iOS XC. I haven't seen this in iOS XR with the, I haven't seen it because they have enabled unicast, which is a totally different AFI, sub AFI. But here you can get that an XE, you can at least get the next hop self all command, and that is important because when you're trying to move from one routing domain to the next routing domain, the ASBR in the middle is where you want to go. If you don't add that command in there, here's what's going to happen. You're going to see the next hop as the PE all the way on the other side, but you don't even know how to get there, so you can't see the route. So let's take a look at it here. Now, I'm not going to go through the OSPF configurations. If you know OSPF, you should be able to configure OSPF perfectly. The things that I want to show you here is at the ASBR level. So let's click on 4. Don't tell me 4 died on me already. All right, I think this died on me already. So let's get out of this. And I'm going to actually go to back. Because sometimes EVNG acts weird for some reason. So let's go back into here. Now, if this does die out, I may have to reboot it and boot it back up. So let's just take a look here. Yeah, so obviously it was the native console acting funny here. So let's go and let's take a look at a couple things. Now, from a BGP perspective, that's all we're going to really look at. I can show you ISIS as well. So I'm going to show you the loopback is in 2 domains now. So the first thing is going to verify that the loopback is in 2 domains. As you can see, it's a normal ISIS process, and then it's an OSPF1. That's critical here. And then when we look at router BGP, we're going to see from a configuration standpoint, we have, I use my template pairs, and I created a couple of them just for testing purposes. But the one that you see the most is going to be RRs, and I believe this NSA, which is, I just said next hop self all IPv4. The key commands here are going to be send label, going to the PEs are going to be route reflectors, so you're going to have the route reflector client, next hop self all send label, and then going to each of ASBRs, we're just going to have the next hop self command and send label because we're going to advertise. Remember, we're advertising that loop deck in the BGP from the PEs, and then we're going to send the label along with that advertisement. So when it hits the ASBR is going to say, okay, all the ASBRs in the middle, when you want to get to that loop back on the other side that I know about, you're going to go through me. If you take that command out, pretty much can't get there because the other ASBRs and the other domain on the other side won't be able to get there because it doesn't know anything about that loopback in its routing table. All right, and we'll validate that on the PE side so you can see I don't know anything about that route in the normal IGP. I know through BGP, but I don't know through the IGP. So that validates no redistribution. The reason on the RR side, the route reflector side, again, I'm not doing BGP full mesh in the routing domains outside of ISIS. So I have to make it a route reflector client to avoid the BGP full mesh requirements. Now, you could do confederation, but not really trying to mess with federation right now. There are some disadvantages in using the route reflector, and if you look at my video on optimal route reflection, I'll tell you what the disadvantages of using the route reflector is. But confederation also has its own downfalls as well. But in this template or peer policy, what we have here is a route reflector client command, next hop self all command again, and a send label. Right now, the next hop self all command again is for IBGP and EBGP routes. So if you use that, it's for both. Now scroll down. We have our normal cluster ID, router ID, stuff like that. I like to use templates because if I want to make a change, I just make a change to the template instead of having to go to each individual thing and change it. I just make a peer template, or peer session template, or peer policy template, and I make my commands in there. As you can see, we have neighborships here. We have IPv4. This is strictly for my PEs, loopback, and then we have VPN v4. All right. Now this setup is pretty much the same on all my ASBR. So 4, 5, 7, and 8. P routers are 11 and 12. These two here. So let's just go to a simple I'll go to one. Now I do have some. I don't just do BGP as your PE to CE connection. Most service providers will not let you do OSPF or RIP, or ISIS or EIGRP as your PE to CE connection. They usually strictly force you to do BGP because it's you can do so much with BGP. So they don't really allow you to do, or rarely will they allow you to do an IGP in the BGP. But I do it here for practice here. So I didn't do the RIP one. I did EIGRP and OSPF. So we go to ISR2 here. Slide this over so you guys can see it. We go into here now. I'm going to validate that in OSPF, I know nothing about the PEs on the other side. So the PEs on the other side here are 6, 13, and 22. And on the OSPF 1 domain, it's 1, 2, and 3. So if I go show IP routes, OSPF, and validate this, all you see is 1, 3, 4, and 5. And then you see the intermediate ones, the routers in the middle here, right? So you don't see anything from a IGP perspective, so I'm not redistributing from ISIS into the OSPF domain. Now, if I do show IP route UDP, now you do notice I do see 6, 13, and 22. Now, the key to this here is if we're looking at a couple of things. So let's look at this, the MPLS forwarding label here, or the forwarding information base, or label forwarding information base. And we see a whole bunch of labels. Now, I didn't do prefix suppression. That's why you see a label for every, little slash 31 here. Now, if I was doing something like segment routing, you would see a dash A in here for adjacency SID, and then the loopbacks would be prefix it. And I'll get into segment routing probably in another video later on down the line. So let's see if we can see. Now, if you have a large information base, you're going to have a problem with this. But as you can see, you do not see a label in the LDP. This is important. You don't see a label for LDP for 10, 255, 2256-32. So if I'm doing MPLS, how do I get there? It's being advertised by BGP. And if you remember, I'm going to keep stressing this, there are 4 ways to generate a label: LDP, RSVP, segment routing, BGP. What we're doing here is we're going to do it for BGP. So if you want to see the label that's generated from BGP, you can show BGP, IPv4, IPv4 unicast. We're going to give it the destination, and I'll do detail on this. Let's go here. And as you can see, here's your label right here. So it's 422 coming from router 4, and this is specifically why I like to dictate what the label ranges are, because I can just look at the label and say, okay, that's router 4, and then this one is router 5. All right. So depending on the path it takes, you're going to see the service label, then you'll see this PE label, or that label for the PE, and then you'll see the one going to the ASBR. But this is being advertised via BGP. It wasn't in the LDP, the lib label forwarding, normal label forwarding information base. It was actually advertised via BGP. You would see this also, and I think I said it in the last video, in Inter AS option B. You would see this in Inter AS option B, which you're going to allow BGP to, well, you allow BGP to send a label. And option C is that as well, because option C is redistributing of internal routes, stuff like that. When we get to Inter AS VPN, so if anybody want a question about that or a video about that, let me know in the comments. So that's the label coming from BGP. I showed you the information, the lib as well, or the LFIB. I keep calling it lib, but the LFIB. And then I showed you that it doesn't exist in the LFIB. So now, with BGP, so we look at BGP here, we're going to see the same significant commands here, which is, you're going to see my template. Let's go down here. So my template is pretty simple. It's just a session template. Apply the session template. Now this is the key parts here. send label. We're going to activate the neighbor, and then we're going to use the send label command, and then this, whenever I advertise, it's going to get a label because I use this send label command. So if I advertise my loopback, it's going to be a label with it. All right, and then VPN v4 is for your traditional VPN v4 stuff. And then here I got OSPF, so I'm doing redistribution of OSPF into BGP, mutual redistribution, so I'm redistributing BGP back into OSPF. And if you were to look at OSPF, you will see a VRF here for 3. Here it is. BGP OSPF v3, and then redistribute BGP in there. And then this is just me being absolutely lazy with this network 000 235 area 0. Super lazy. Would not advise you to do this, but I just did it in the video. So, I didn't have to avoid making any mistakes or not activating OSPF on a certain interface. So now, let's go back in here. Some bricks, whatever this wants to go back. So now, if we were to look at we're going to look at the VPN v4 table, and then we're going to look at the VR table. So we look at BGP, VPN, v4, unicast, all. That's the VPN v4 table. And if you wanted to, this is basically to validate that you got routes in the VPN v4 table. This is the table I like to call it. Now, all these routes can have its own respective RT values. Now, all of them in this lab have the same RT value. But if you had different values, you can still see it in the VPN v4 table. It just won't be in the VRF, right? Remember, the RT value is your, I gotta be careful using this. A lot of people use this, is your VPN membership. Really, all it is, hey, I'm going to look into the VPN v4 table. Anything that I say import with a certain route target, I'm going to look at the VPN v4 for that route target, and then I'm going to import it into the VRF. And then from the export perspective, I'm going to export it with a certain route target value. And if anybody wants to, quote unquote, join the VPN, you just got to import my export value, right? That's really it. Now, there's a couple. I'm going to focus on this route here, which is 10.255.255.27, and we're going to take a little bit closer look at that. Let's go 10.27/32. Can I be detailed on this? Probably not. All right, so let's go here. And as you can see, here's the VPN label for it right here. Another VPN label for it right here as well. Right? Now you're getting it from 2 different route reflectors. As you can see, we're getting it from 4, and then we're getting it from 5. All right. Here's your community value, like I was saying, right here, which is the 65001 colon 65001. This is just, again, the RT value. I exported it with this RT value, so if I import it with the RT value, it'll be in the routing table. Now, I believe this is an EIGRP route because there's a certain thing called pre-best path selection. You have to be careful with this with EIGRP. A lot of this other stuff here is basically the metric values that you re-import with, right? So when you redistribute back into EIGRP or OSPF, what can end up happening is you're going to see these metrics for whatever metrics you put in the OSPF and you redistribute it in BGP, come back the other way. It takes those values in the BGP and makes this here. Now this pre best path selection, you got to be careful because this happens before the best path selection. This is kind of the it's the pre-best path, but it takes precedent over everything else. So you can mess with the mate, local preference, med, AS path, origin, all that stuff. If the pre-best path says this is the best way, it's always going to go that way. Now you can ignore that using, I think it's BGP best path community BGP best path community ignore. I believe that's the command. Don't quote me off the top of my head. But you use that and then you ignore the P best path selection or metric. So that's everything there. So all this has been set up. Same thing on this side as well. So what I'm going to do, yeah, 27 was EIGRP route. So that got redistributed into here. And then when I looked at it on the other side, it took those whatever metric values and then put it into BGP. That's why everybody loves BGP. So what I'm going to do here, we'll do something very simple. We're going to pull up 18 here. And just make sure you guys can see this. And we're going to do a trace route from the loop back on 18 to 27. So that loop back is actually on router 27, as I showed you over here. Let me slide this over here real quick. And it's that router right here, and it's loop back 27 here. So first things first, we're going to validate if we can actually see the route. So let's just do show IP route. I'm going to do EIP, fill out the route in there. So this is 27. As you can see, it's a D route. So for our CCNA, CCNPs out here, the D route is basically, it's using the same ASN number. So I'm using ASN 100. So it looks internal, right? That's why the administrative distance is 90. 90 is the administrative distance for internal, 170 is for external. Remember, learn your ADs, your administrative distance, because you might be quiz on those. And the one that trips everybody up is 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 115. So what this is saying is 10.255, 255.27. We're going to go to our PE. Now we're going to validate the ping test first. So we're going to ping 10.255, 255.27 from the loop back just to verify reachability. As you can see, so we have successfully went from OSPF 1 to ISIS to OSPF 2 when I popped out the other end. So now let's look at it from a trace route perspective. Remember, we're going to see 3 labels. And then after we see those 3 labels, it will go to 2 labels, then it will go back to 3 because it pops off a label, then it gets to ISIS, and it puts the label back on. So we'll see here. Well, let's do the same trace route. Trace route. Now, the reason why I didn't take off, or I didn't do the command no MPLS IP propagate TTL, because if I did that, you wouldn't see this trace route working. Normally, service provider do that when they don't want you seeing their internal network. 27, we'll source it from the loop back, and then we'll wait. So what's going to happen is that it's going to go through the loop back, and I want you to pay close attention to the label stack. So that's the PE, the ingress PE, and then the next should be the label stack. So as you can see, 3103, that's router 31. The It's going to 4401, and then this label here is the service label. And we saw that when we looked at the BGP configuration. So this service label is here. So now it got to the ASBR, still has the same service label. And then it's going to put back another label. So you're going to see 3 again. Here's the 3 labels again. So this is router 7 now. This came from router 12 to 7. All right, now we're at 7 because it's 729. Remember, I specifically labeled my label so I know what router is in. And then it went to 36. And then it went to 38. And then the PHP process should happen, and you should only see the service label. There's the service label, which got ultimately to the end, that router before, which is this one here, is 22. And then 22 sent that label as an IP packet after it stripped off the VPN label. And then there you go. So that was complete, seamless, or unified MPLS all the way from OSPF 1 to OSPF 2. And then they don't know anything about how to get to each other from an IGP perspective. It's all BGP over the top or overlay, right? Now, I think I showed you this. The cool part here is about VPN labels. If I were to, it's a local label here. I think it was 22.0. 021. So we can show MPLS label, label 02021 detail. All right, so this is why the lookup is so fast in the MPLS label. This is the VPN label. The key thing here is this is a lot of this is so here's the prefix, and it's the VPN prefix, right? There's no label going out, so this is ultimately the bottom of the stack label. And then the next hop is already imprinted in the VPN label, so it doesn't even have to do the 32-bit lookup once you strip off the service label, because the service label tells you, hey, when you strip me off, your next hop is this. So just send it to that next hop. You don't have to do the 32-bit lookup in the routing table. Tells you it's a VPN route. Obviously, here's the VPN here. Um, and that's really the cool part about the VPN label is, hey, not only is it going to tell me what VRF I belong to, it also is going to tell me the next hop to send this packet to get to where the destination. So I don't know if I said that in the last video, but I wanted to show you guys that from the beginning. So let's look at the. Now, hopefully, I can catch the right. I did it from 18, right? So what we're going to do here is we're going to try to do a capture to see where this label is coming from and where did it go to. I'm assuming it's either going to go to 32 or 31. So let's pull up Wireshark here because I want you to see the label stack in the Wireshark packet as well. So you should see like some OSPF and LDP and stuff like that, which is normal. But we're going to pull up 2 Wiresharks, and then I'm going to do that ping test again, and we're just going to look at the stack here. And let's pull up the shortness just a tad bit. All right, so it came here. Right. And let's go up a little bit. And let's see the request. I'm going to slide this over just a tad bit because as you can see all the labels on there. Slide this over. All right. So remember when I told you yesterday or in the last video, make sure you can look at this from a Wireshark perspective. Because if you can't look at it from a Wireshark perspective, you're going to get confused about a lot of things. Wireshark is your best friend when you want to do deep packet analysis. Get a PCAP, you can be able to, if you can use Wireshark at an intermediate level, it's going to put you way ahead of the game over like a lot of engineers. So they don't really know how to use Wireshark. But a lot of them do. So, and I was one of those people who try to avoid Wireshark, but then after I really started deep diving into Wireshark and looking at how cool it was, I'm an advocate of Wireshark now. Now, if you're looking at these labels, the top label again, these are all top labels. And the top label is the one that gets swapped, right? So this is called, I want to say the right word. This is pushing labels, right? But they call it imposition. But we're pushing labels on top of the ultimately the packet. So this is the ICMQ packet here, or the ping request, but I have all these labels on top of it. This allows me to not have to worry about the actual data at the bottom because I really care about just the label stack. The top label is the one that's going to get swapped as it goes through domain 1 to ISIS to domain 2. All right. And then ultimately, this is the service label at the bottom. Remember, I told you in a previous video, if you look at the MPLS packet, it is 20 bits for the label, 3 for the experimental bits, which is QoS, 1 for the bottom of the stack, and then 8 for TTL. This is exactly what it is here. The bottom of the stack label is the last label. This is usually the service label in the MPLS out to the VPN. So as you can see, right there, bottom of the stack. If that's set to 1, that is the last label in the stack. If it's set to 0 like the other two, it's not the last label. And these are the labels that are going to end up either getting popped off somewhere down the line, right? And then where's the reply? So the reply comes back and it doesn't have all that stuff because it was stripped off before. Again, bottom of the stack label though, that's what you will see on the reply in Wireshark. You will see the bottom of the stack label come back because the other two labels got stripped off. So that is unified or seamless MPLS in a nutshell. It's it's a lot of moving parts, right? A lot of things that you have to remember, especially that next hop self all and the send label. You have to know from sequentially how it works. But from an advantage standpoint, I can add multiple domains here and just make sure I hook into my router things here in the ISIS domain, and I keep my fault domain very small to its respective domain. If something happens in OSPF 2 from like a link go down or something like that, and I have to flood LSAs, I'm only flooding LSA within the domain, not in domain 1 or the ISIS domain. If this was one big OSPF or ISIS domain, well, you can run into problems if there's a problem over in one of the sections. And I'm talking about not running incremental OSPF or ISPF. If you're not running ISPF, which only is going to run the SPF algorithm on the broken pieces, let's say you don't do that, well, you could have a flood depending on how big that domain is. Now you have, micro loops and things flapping and network instability and stuff like that because one part of the network is affecting another part of the network. When you do stuff like this, you're isolating the fault to its respective domain. It's the same thing as multi-area OSPF. If you have the core is OSPF area 0 and then everything else ties to area 0 in different areas like 1, 2, 3, 4, well, there's an issue in area 1, it doesn't affect area 4. Hopefully this video was informative. I really like doing these labs for you. I got another lab coming that's going to be really cool. Don't forget to share, comment, like, and subscribe. If you're watching this video, it doesn't really kill you to share or like the video. So I would really appreciate it if you guys just share, comment, like, and subscribe. This is Don from Padlock Technologies. Thank you and have a nice day.